to record, subtract 14, and I get x squared plus 5x minus 14 equals 0. Factor x minus 7, x minus 2, so x is going to equal, x plus 7, so x is going to equal negative 7 and positive 2. Wow, going too fast. Subtract 3, and I get 3x squared equals 72. Divide by 3. X squared equals 24, square root. So x is going to equal plus or minus, 24 is 4 times 6, right? So that would be 2 root 6. Okay. And then 3, subtract 24, add 7x. So I get 5x squared plus 7x minus 24 equals 0. So A equals 5, B equals 7, C equals negative 24, minus 7, x equals plus or minus the square root 7 squared minus 4 times 5 times negative 24, all divided by 2 times 5. It's going to equal negative 7 plus or minus the square root of 49 plus 480, all divided by 10, which equals negative 7 plus or minus the square root of 529, all divided by 10. And then the first thing I do is find out what the square root of 529 is. So it's 23. So I always put that into square root first. So plus or minus 23 divided by 10 is going to equal minus 7 plus 23 divided by 10, and minus 7 minus 23 divided by 10 simplifies to 8/5 and negative 3. You forgot the negative, by the way. That's how the first one, the half of the first one was wrong. Unless I read it wrong, but I didn't think I did. Okay, so that's the answers for that. Okay, so now we're going to go on. We're still solving polynomials, but we're doing degrees greater than 2 now. So cubes and quartics and quintics and greater degrees. Okay, so first we're going to talk about the fundamental theorem of algebra. It's pretty easy. It just says any polynomial of degree n has n roots. But we may need to use complex numbers. So if it's a degree 6, it has 6 x-intercepts, or 6 roots. They may be imaginary roots. They may be complex roots, but it has 6 roots. And we may not be able to find all of them because they're imaginary. So depending on how we solve it. But that's what it says. So if I have a 3rd degree polynomial, then I should have 3 answers. 2nd degree should have 2 answers. Just that's how that works. So to find the zeros of function, we need to solve the equation f of x equals 0. In general, the degree n of the polynomial function tells us how many solutions or roots the equation f of x equals 0 has. A linear equation has 1 root. Quadratic has 2 roots, solving it different ways, which we already know those. We know those ones, right? A line has 1 x-intercept. A quadratic has 1, 2, or 0, depending on where it's sitting, right? So it can have 2 imaginary roots if it's above the x-axis, the vertex is above the x-axis and it's opening up. It can have imaginary. It can have 1 if it's sitting on there. It technically has 2 at 0. It's a multiplicity. We're going to talk about that next time. Or it can have 2 real roots. Okay, so, and that's the same with polynomials. So we still have the zero product property. If I have several things multiplied together equals 0, one of those several things has to be 0. And the root property. The difference on the root property this time, instead of saying a squared equals b, it's a to the n equals b, equals a equals plus or minus the nth root of b when n is even. So if I have any even root, I will always have a plus or minus. I'm sorry, any even exponent, I will always have a plus or minus, okay? If I have an odd exponent, it will just be whatever the root of that number is, okay? Because I can have an odd exponent like the cubed root of -8 is -2, because -2 times -2 times -2 is -8, right? So that only works with odd exponents. That's it. That's what we're going to do today. Luckily for you guys, everything we're doing is already factored. So we don't have to do long division or mostly factored. So it'll be mostly factored down to a quadratic, okay? And you might have to factor the quadratics. So not too hard, okay? So let's flip to the second page here. Super easy, honestly. What's my n? So it's always going to ask what my n is. And really how I do it is I'm going to count my highest degree in each one. So, this is first degree, first degree, first degree. So that means my n is 3. Okay, so I should have 3 real solutions. Now, if I don't have 3 real solutions, that probably means I have some imaginary ones. I'm not going to be able to find them today. Okay, if we put it on a graph, we'll probably be able to find it. And we'll talk about what the imaginary solutions look like on a graph next week when we get to graphing. Okay, so we're not going to really worry about finding the imaginary roots unless it's pretty obvious that we have the square root of a negative number, then we can find those ones. But if it's not obvious, we're not going to worry about finding them right now. Okay, so this is just like what we've been doing with the quadratic, right? So I have x minus 5 equals 0. I have 3 things multiplied together that equals 0. One of them has to be 0. X plus 2 equals 0. And 6x minus 8 equals 0. So therefore, x is going to equal, if you guys do not get what the answer is or how to find the answer when I just write it down, please let me know. X is going to be equal to positive 5, negative 2, and positive 8 divided by 6, which is really 4/3. 4/3. Okay, sorry about that. Any questions on that? You guys at home? Anybody have any questions? Okay, and then the next one, finding n, I'm going to find my highest roots again. So I've got a first power and a second power. That means my n, when I multiply those together, I'm going to get n cubed again. So my n is 3. So when I solve 2 things, so actually I have to see if I can factor the parenthesis this time. So I'm going to have x times x minus 3, I think it is. Yep. So x equals 0, x minus 3 equals 0, and x minus 3 equals 0. So x is going to equal 0 or 3. Okay. Notice in this case, my final answer, I only have 2 roots, but when I wrote it out, I would have 3, but just 2 of them are repeated. So I technically have 3 roots, just one of them is repeated twice. Okay? And there's a name for that. It's called multiplicity. We'll be talking about that. Okay, so now we're going to have you guys try it. I want you to tell me what my n is, and I want you to tell me what my roots are. Okay, so let's go with these 4. This is a lesson we should have done on the hour day. Okay, so I just realized, by the way, that my iPad is much smaller than what's on your computer screen because I never see what's on my computer screen. So sorry that it was really small on your computer screen because my iPad, you can't see it. So sorry. This is the first time I've actually seen it on the computer screen and my iPad at the same time. So, this says, 5x plus 1 equals 0, x minus 4 equals 0, and 3x plus 2 equals 0. So I'm going to solve one of these just because there's some funky answers for these in the chat box. So I'm going to subtract 1, and I get 5x equals negative 1, divide by 5, and x equals negative 1/5, right? You add or subtract a constant and then divide by the number with x, and that's how I get my answer, just like when I'm solving for x. And I have an equation. It's the same thing. Yes, I know. You're not the one I'm talking to. Okay? Or ones. Okay. So, and then the next one would be 4. And then this one would be negative 2, subtract 2, divide by 3. So negative 2/3. And if I multiply this x by this x by this x, I get x to the 3rd. So n would be 3. Okay? And then if we go to B, I can write this as 2 times x minus 2 times x plus 1 times x plus 1 equals 0. And this 2 out front, this little 2 here, doesn't mean anything because I can do this. I can divide this side by 2 and this side by 2, and then that 2's gone. This 2 goes away, and I get x minus 2 times x plus 1 times x plus 1, 1 equals 0. And then x is going to equal 2 or negative 1. And my n, I have x, an x here, and I have 2x, well, I can do it here. X times x gives me x cubed, which my degree is 3. Questions? You guys okay? Awesome. Any questions in the chat box or from you guys at home? All right. So, oops. Okay, C, there was just a question on, because this has an x with it, I'm not going to divide by 2, but I can. I can divide by 2, and then it would just be x by itself. That's fine. Or I can leave it as is. And then this becomes x minus 2 times x plus 1 times x plus 1 equals 0. So I have, I'll do my, yeah, that's just, 2, I don't know how I want to say this or what I want to do. Let's just do this. So I know that this first one is 2x equals 0, and then the rest of them are just like what we've been doing. So I know that x equals 0, 2, and negative 1 again. But I've got x times x times x times x. So that's x to the 4th. So my n is 4. Questions? Anybody? Are we okay? Awesome. And then this one, almost everyone missed this one. Okay? So, equals 0, right? So I've got 5x plus 1 equals 0. I'm just going to write this one out. X squared minus 9 equals 0. And x plus 9. Oh, no, let's not write it out that way. Let's not do that one. Let's do it this way. 5x plus 1. I can factor this. This is factorable, right? I can factor that to x plus 3 times x minus 3. And then this is x plus 9 equals 0. Is that a better way to think about it? I can think about it that way. Or I can also say, if I wanted to write that x squared minus 9 equals 0, I could add 9 to both sides. And I get x squared equals 9, and you take the square root of it, and x equals plus or minus 3, which I'm going to get if I solve here. So either way you want to think about it, there's 2 different ways to think about that. x squared minus 9, because the squared is on the inside of my parenthesis and not the outside, so I can think about it two different ways. So that means x is going to equal subtract 1, divide by 5, subtract 3, add 3, subtract 9, and then I have an x times an x times an x times an x, which is x to the 4th. Questions? So almost everybody forgot the -3. Not in this case, x would not be 0. Okay. All right, and there's 2 more questions. Some of you probably already have them done. I know that some people already put the answers in there in the chat. Shh. And I need to look at something. Oops, sorry. Go back up, please. In here. Yes. Oh, great. Okay. Oh, no, that was solving quadratics. Okay, that's what okay, that's why I was confused. Not confused anymore. Yes. Nice, Yellow. Good job. Yes, Conrad. Good job. Let me see. Oh, sorry, Conrad. Let me look. So close. Remember what happens if I have an even root, an even exponent. Okay. Are you guys done? Do you have questions? You're good? You guys are good. You guys are so quiet even in here. Yes, of course there is. We're going to talk about that in a minute. So I'm going to say this. I know I told you that we would figure out how to find, I would show you how to find the imaginary roots later, but I think I'm going to do it today. Just because you guys are honors class, so we're going to show you how to do it today. I know. You guys are honors. You should know how to do this. Right? Like, right, Miss Campbell, whatever. So we're going to start with the easy one, because this will be the easy one to find. Everyone found the real root. What's my real root? X equals what? Anybody? You can say it out loud. It's okay. Yes, thank you. 1. Someone in chat said it. X equals 1, right? So that's my real root. So, but remember, I can this is a cube, right? X cubed, 1 cubed, right? 1 cubed is 1. So I can factor this. I can factor a cube. It's been a while since you've done it, since we've done factoring of cubes. It's probably been a long time since you've done factoring of cubes. But we can factor this. So it says this. If I have a cubed minus b cubed, I can factor that to be a minus b times, I want to make sure I say this right, a squared plus a times b plus b squared. So I can factor this beautiful x cubed minus 1, it's nice and simple, into this great big huge ugly thing in order to find my roots. So we're going to do that. A equals x and b equals 1. So all I'm going to do is substitute in to here, this part right here, and we're going to find the imaginary roots. We already know what the real root is. So, so I get, let's go ahead and do this. Sorry, I'm going to change this. So this factors to x minus 1, which we already know that x is 1. And then it factors to x squared plus 1x plus 1 squared is 1. So it factors to that. That is not factorable. Doesn't factor. So how do I solve a quadratic that doesn't factor? Anybody? We did it last class, so you guys should know how can I factor that. Or how can I solve that? I can use the quadratic formula, right? So A would be 1, B would be 1, and in this case, C would be 1, right? So they're all 1s. So I get minus 1 plus or minus the square root 1 squared minus 4 times 1 all over 2 times 1. It's a lot of 1s. Minus 1 plus or minus the square root of 1 minus 4 all over 2. So negative 1 plus or minus the square root of negative 3 divided by 2. Or negative 1 plus or minus I root 3 divided by 2. So there's my 2 imaginary roots and my real root. So if it's a cube, and if it's a perfect cube, I can factor it. It's really ugly, but I can find my real root. So you guys need to know how to do that. And it's a possibility it'll come up. And if you're taking concurrent next year, it will definitely come up. If you take college math, it'll definitely come up. I know, I'm sorry. Which means all of you guys will see it again, because I'm sure all of you are taking college math, either in high school or in college. Even if you're going to become an artist, you still have to take math. I know, because I still had to take language arts. I was so happy I wouldn't have to take language arts. Not true. Okay, and then the last one, you guys are right, it's N5. Everyone got that right, very good. So I have two equations, and I'm just going to find the real roots on this one. I can find the imaginary roots again on this one because this 8 is a perfect cube, right? So it's 2 cubed, right? So I could do it. We're not going to on this one. I just wanted to show you so you're aware that we could do it. Okay, so this would be x cubed plus 8 equals 0, and x squared plus 8 equals 0. Well, we're going to find one set of imaginary roots, by the way. So subtract 8. There's 4 imaginary roots in this problem. And x squared equals negative 8. Square root, cubed root. So x equals negative 2. And plus or minus, and this is where, right, because the square root, it's an even exponent. If it's an even exponent, it has both a positive and a negative answer. And 8 is 4 times 2. So that would be 2i root 2, because it's a negative 8. Questions? Does that make sense? She's like, I don't know, Miss Campbell. Square roots. It's just solving. You've solved stuff like that a lot. Okay, so let's go ahead.